Hello everybody, welcome to my channel. Today we have an amazing problem for you guys, right? It's called remove duplicates from sorted array, right? This is going to be a very good problem, so make sure you pay close attention to it, all right? So the question is again called remove duplicates from sorted array, right? So it says given an array nums, right? Sorted in non-decreasing order, remove the duplicates, right? In place, okay? Such that each unique element, right, appears only once, okay? The relative order of the elements should be kept the same. It says then return the number of unique elements in nums. Okay. It says consider the number of unique elements of nums to be k. To get accepted, you need to do the following things, right? Change the array num such that the first k elements of nums contains the unique element in the order to represent it and the nums initially. Okay. The remaining elements of nums are not important, as well as the size of nums. Okay, return k. So to just clarify everything, right? So we'll be giving this array nums, right? And then we need to return the k unique elements, right? And those numbers will be occupying the first k spots, right? So from 0 to k minus 1, right? Those unique numbers should be, that's where they should be at, right? And then we're going to return k, which is going to be the number of unique elements there are in the array, right? So those are two things we need to do, right? So make sure that, all the unique numbers occupy the first k spots, right? And then not only that, return the k, which is the number of elements, right, that are unique in the array, right? So very important to do, okay? So it says again, so the judge will test your solution like that, right? So very similar to another problem that we've done, right? So so let's go through example to solidify the concept, right? So they're asking us to do the ask, right? So we're given this nums array, right? And we could just tell there's only two numbers that are, two distinct numbers, right? 1 and 2, right? One is a duplicate, right? You know what I'm saying? So we just want the unique number of elements, right? And we can see there's only two of them, 1 and 2, right? For this one, it's the same thing. We see something like, we see a 0 here, we see 1, we see 2, we see 3, we see 4. That means there's about 5 numbers, right? And that's why we return 5 distinct numbers, right? There exist, and then the 5 numbers are occupying the first 5 spots, right? Right, spot number 1, spot number 2, spot number 3, spot number 4, and 5, right? From index 0 to k minus 1, right? That's what those numbers should be occupying, right? And those underscores here that they have here, right? They don't matter. That's why they just put underscore, right? Doesn't matter what you put there, right? You could put random numbers, doesn't matter, right? Those numbers aren't gonna matter, right? So they're only gonna be checking the first k spots, right? And then to make sure that the numbers that should be there are there, right? And the order matters as well, right? That's what they're saying. So it's very important, okay? So we know that this thing is sorted, right? Okay, so that's a good thing that they're telling us as well, okay? So how do we go about solving it, guys, right? What's the easiest way, most straightforward way of going about it? We're not trying to be overly smart. We just want to do the intuition, right? Off the bat. You could probably think of, straightforward way, or I'm thinking to use some kind of a data structure, right? That's the easiest way I could think of, right? Use a data structure that can help us in knowing, keep track of unique elements, right? That's a set comes into mind, right? Pretty good time complexity, right, for retrieval and adding stuff to it, right? So it's pretty good, but that will require some kind of additional space, right? Because we would need to loop through, right? As we're looping through, add all the elements into a set, and then check the size of the set at the end, right? And then that would be right. Not only will we use space, right, but we would need to also make sure that we loop through the array again, right? Add all the unique numbers for the first k spots, right? This could be good. I think it'll be decent enough, right? But the constraint says in place. So that means that we can use additional memory, guys, right? So how do we be more clever, right? Okay, so this is very similar to a problem that we've done recently, right? And we've gotten good feedback on that problem, and I advise you guys to go check it out. It's actually very well explained, but I'm about to explain again in this video, right? So I'm thinking we need to do some kind of, we need to loop through all the elements, right? Okay. And as we're looping through, right, we also need to make sure that we somehow can place the numbers that we find, right? The numbers that we find and put them in particular spots, right? You know, do we need to do some kind of a formula or something that lets us know where to put certain numbers, like how to do that, how to do this, right? No, it doesn't need to be that complex. Actually, it's going to be a lot more intuitive and easier, right? So we know that we need to loop through the array, right? We have to loop through all the numbers, right? So the time complexity is going to be of n at least, right? And as we're looping through, we need to find a way to know in which position we could put, right? Okay, so that's why we will be introducing another pointer, right? So one pointer is going to be iterating through the array, and the other one's going to be behind, right? And be able to allow us to put numbers in the correct position, right? So we add a number at one position. Let's say we add a number at the first position in the array, right? We would increase that pointer, right? Every time we add a new number to a one spot in the array, right? And then we keep looping through, right? Until we reach the end of the array with the other pointer, right? Okay, so this will be very similar to our problem, right? So how do we know when to add a number, right? That's when the condition is going to come into play, right? We need to keep thinking about it, right? We'll need to somehow know when a number is a dupe, right? And when it's not. Okay, so one way we could go about it, right? This example can show it a lot better, right? Maybe we can loop through, right? Every time we encounter a new number, right? Which is, we define that we encounter a new number when we check our previous number, right? We check if the number that I'm on right now, right, is it the same as the previous number, right? If it's not the same as the previous number, then this is the first time we've seen that number, and we're going to consider that number to be a unique number, right? And then we're going to add it to our output results, right? Okay. And then we're going to keep doing it every time, right? We count the number, we add it to the output result, right? And then we keep doing that so forth until we reach the end of the array, okay? So the first number, right, we're going to consider it to be a unique number, right? We're going to add it to the output result as we go along, right? And then we're going to be skipping all the other ones that are duplicates, right? Because we're going to know that because we're going to be checking each number, right, with its previous number. So we check, is this the same as the previous number, right? It is the same, then we can skip it. We don't need to add it, right? Then we go to the next number. We see that, is this number the same as the previous number, right? No, it's not the same, so we add it to output results, right? And as we're adding it, guys, right, one thing I forgot, right, we increment the other pointer, right? So I'll go through a quick example with you guys, right, to solidify the concept, okay? So yeah, this is the drawing board, guys, right? So let's quickly go through the example, right? So the first number will be the number that's we're going to consider that number to be our first unique element, right? So it's going to stay there. We're not going to modify. It's going to stay the way it is, right? And as we're looping through, right, we're going to have, so the J pointer is going to help us in looping through the array, right? And then the I pointer is going to help us in placing numbers at those particular spots, right? Okay. So every time we encounter a new number, a new unique number, right, we add it to the whatever place that the I is pointing at. We modify that place, right? And then we increment the I pointer to go on to the next spot, right? So we can modify it as well, right? And it's by doing that we'll be able to modify the array in place, right? And be able to find the unique numbers and then add them at the spot at the beginning of the array, right? This is a very important concept you need to wrap your head around, right? So this is two-pointer technique is used in a lot of different problems, okay? So let's go ahead and start, right? So we got this, so the J and I pointer point at the same spot initially, right? And then we check, right? Is this number the same as the previous number? Yes, it is, right? It is the same as the previous number. So we're just iterate through and I stays where it's at, right? And then we check, is this number that the J is pointing at, is it the same as the previous number? No, it's not, right? Because it's not, we're going to update that value, right? You know, so now this value, right, is 1, right? Right? So we add that number. That's a new unique number we've seen. So we make sure we add it to that spot, right? So 1 is the value at index I, right? So now both pointers will be moving forward, right? Not only J, right? So J is gonna move regardless, right? Right? And I will only move when we encounter a new unique number, right? So we've encountered that, right? We move I because, guys, right, we've already at that number at that spot, right? So we need to move to the next spot. So that's the next available spot that we have that we could add a new unique number to, right? That's why I moves forward. Okay. So we check, is this one the same as the previous one? Yes, it is, right? Before we just go ahead and move forward, right? It's the same one, so it's a duplicate, right? We check, is this the same as the, yeah, it is the same, right? We go to this one, right? We check, is the 2 the same as the previous number? No, it's not, right? So therefore, we're going to remove that. And now the new number here is 2. Okay. And then now, this is the time for, both numbers to move forward. Okay. Both pointers to move forward. Okay. And this J has to move forward as well, right? We go here. We check, is 2 the same as the same? Boom. We go here. Boom. Is 3 the same? No, it's not, right? And then we know what time it is. We remove that. We put our 3 here, and we move both pointers forward. Okay. Move it. That now I points at this spot, right? That's the next available spot. And then we check, is 3. Is this 3 the same as this 3? Yes, it is, right? Is this 4 the same as? No, it's not, right? So therefore, it's another spot we could do. Okay. We update that value there, right? And then both pointers move forward, right? Move forward here. And this goes out of bounds. Then we exit our while loop, right? And we are done. And yeah, so now we return whatever index, right, the I is at, right, to signify how many numbers are unique, right? So we got 1, 2, 3, 4, 5. There are 5 unique numbers, right? And then they are occupying the first case spots, right? For 5 spots. Okay. So just like that, guys, we are in good shape, right? So hopefully you guys were able to understand the thought process and the example, right? So let's quickly go into the code, right? So it's gonna be relatively simple. We have a J pointer and we have a I pointer, right? Which starts at index 1, and I've already explained why. Right? We consider the first number to be the first index in the array to be a unique number, right? And then we're going to be checking, guys, right, with so we have the J pointer that's going to explore the array, right? We have an explore pointer, right? And yeah, and then the I pointer is going to stay behind and helping us placing numbers at the spots at the beginning of the array, right? So we know that J is going to be moving regardless, right? J plus plus, right? We know that. So now this is where we introduce the if statement that would decide when we should move the I pointer, right? After placing a number at a particular spot, right? So if the number that J is pointing at is not the same at the number of the previous spot, right, as the last previous number, then we know that, this is the first time we've seen that number, right? So we add it to the output, right? Okay. Then we had that number that the J is pointing at, and then we move the I forward, okay? That's the only time we're forward. Once we add it to a new spot, right? And then we move it forward so that we can modify the next spot, okay, that we could place. And then return I at that point, right? So it looks good to me. Let's press run code, see if we pass the small test case. Let's press submit. Awesome, guys. We're able to pass all the test cases, guys, all right? So if you guys found value, you guys enjoyed this video, let me know that in the comment section, right? If you're new here, subscribe. We do a lot of new videos every weekend. Subscribe, and yeah, I'll see you guys in the next video.